prediction equations because I realize this too is going to be review. It isn't brand new to Algebra 2. What you want to be able to do is draw a scatter plot, draw a line of best fit, determine the type of correlation, and then write the prediction equation for your line of fit and use that to make whatever predictions the problem is asking you for. So I have just on the front definitions that you need to know, and the first one is bivariate data. So the data in a scatter plot is bivariate data. It's data that has two variables. It's typically x and y. And when you graph that data on a coordinate plane, that's what makes the scatter plot, or that's how it's defined. So it's also called a dot plot. Typically, we call it a scatter plot. And then a scatter plot can show whether there's a positive, negative, or no correlation between two variables. So correlation would be, in this instance, a linear relationship. So does your scatter plot seem to fall in a linear pattern? Does it have a linear trend or not? And then with that, is it a positive linear trend or a negative? We can also describe correlations as strong or weak. In a strong correlation, the points of the scatter plot are closer to the graph of the line of best fit that you would draw in than the points representing a weak correlation. So we'll review this when we actually go through example 1, but when I ask you to describe a correlation, not only say is it positive or negative, unless it's no correlation, but then also say if it's strong or weak. So this does give you visual representations of positive, negative, no correlation, and then the positive one is representing a strong correlation, the negative one is representing a weak. So a strong, or rather let me talk about positive versus negative first. Positive correlation, so the scatter plot seems to follow a linear trend. The line that you would draw through it would have a positive slope. So then it's a positive correlation. So from left to right, it would seem to be increasing versus in a negative correlation. Left to right, data seems to be decreasing. The line drawn through would have a negative slope. And then, again, another difference between the two, the first one, notice the points are closer to that line of fit. So that would be considered a strong correlation. They don't exactly form a straight line, but they're pretty close to the line of fit. Versus in the second one, those points tend to be more spread out. They still form a line or a linear pattern, but they are more spread out. So that would be more of a weak correlation. And then no correlation is just if you have this random scattering of points, they don't really seem to follow a linear trend. So then when you find a line that closely approximates a set of data, you're finding the line of fit for the data. And then when you write an equation for that line, that's what's called the prediction equation. And it's called that since we use it to predict one of the variables given the other variable. So thinking of why you would even use a scatter plot, typically it would be used to predict future occurrences. So maybe a business wants to predict future costs or even future profits. So they might have a scatter plot of, so many years to predict what's going to happen in the next 10 years or something like that. So then to find a line of fit, the last thing on here before we get to the example, to find the line of fit, you select 2 points that appear to represent the data well. And it does say on here I included, it's a matter of personal judgment. So your line and prediction equation may differ from those of others. So this is an area in this chapter where there is not just one right answer. It's still possible to get it wrong. So you can still have a wrong answer, but there isn't just one right answer. How you draw your line and what points you choose to write your equation is all up to you, and you could have a different answer than me, you could have a different answer than somebody you're sitting by, and we could all still be correct. But like I said, it is still possible to get it wrong, so I'll kind of show instances where you would get points off or things wouldn't be correct based on how you're doing it. Okay, in this example I have for you then, we have a table that shows the percent of U.S. households with internet access. And we are going to first in part A make a scatter plot and a line of fit and describe the correlation. And it says let X be the number of years since 1995. So if you have a problem that tells you this, that means when I look up at my table, Notice in the table, X is representing the year, but the actual year is given. This is saying I need to figure out what the X values are based on how many years it's been since 1995. So for example, 1997 is 2 years after 1995, that X value would be 2. So what would the X value be for 2000? How many years since 1995? 5, yes. So then 2001 is 6 years later, 2003 is 8, 2007 would be 12 years later. So rather than putting the actual year on the x-axis, you would be putting those values. And then the y values are representing the actual percent of households. So in 1997, 18% of households in the United States had internet access, and then in 2000, that jumped up to 41.5%. So you want to see the trend of internet access as the years are passing. So this is how on your assignment, you're going to be seeing your grids. I'm just giving you a blank grid. You have to label your scale you're using for your x and your y axis. So I'm just going to draw in the x and y axis. But I'm leaving it up to you how you choose to make your scale, because there isn't one right way to do that either. You typically should just have your axes on the bottom and the left like I drew them. You're in the first quadrant. Most examples aren't going to make sense for negative x or y values, so we're just focusing on the first quadrant where everything is positive. I'm just going to put 0 at that lower left-hand corner. So looking at our x values, we need to have a scale that fits the values 2 through 12. And this is a 10 by 10 grid. So we have 10 spaces for both the x and the y axis. What could we count by for the x's if we have to fit 2 through 12? We could count by 2's. If you count by 1's, you're only making it up to 10. So we could count by 2's. And then for the y-axis, we have to fit the smallest value is 18, and the largest is 61.7. And again, we have 10 spaces. So what could we count by for the y-axis? We could count by 10s. So after I fill this in, I want to say one thing to remind you about when you're making your own graphs. So I could count by 10s, then I clearly fit up through my highest value, and I also fit my lowest value. Remember that for either the x or the y axis, say instead on the y axis I wanted to count by 5s. Well, if I just count by 5s, I'm only going to make it up to 50, and so I'm not going to make it to my last 2 values that are up here, and even 50.4 would be a little bit off of there. But what I could do is I could, let me actually draw it on this board. And this might be helpful later on your assignment because you have larger values to work with, but you may have done this before with making graphs. You can make a little jagged line in your first graph and say, I'm starting at 0, I'm going to jump up to, say, the y value 15, and then from here I'm going to count by 5s. So then I can go to 20, 25. And that would have at least gotten us through the y value 60. So then 61.7 would just be a little bit off of the graph, which is okay. But if you didn't want such a wide range for your scale, remember that you can make a little break in the graph for either of your axes. So I also could have done that for the x-axis. Maybe I wanted to count by 1s, but I want to jump ahead to a different value to start with. I don't want to start with 1. It's up to you. So just remember that you have that option. You can do that. So now on here, I just plot these 5 points. So make sure you're using these x values, the 2, 5, 6, 8, 12, and then these y values. So at the x value 2, I would plot the y value 18, approximately where that is. At 5, I would plot 41.5. At 6, 50.4. At 8, 54.7. And 12, 61.7. Okay, so then once you have your scatter plot, then it says to draw in a line of fit. So first of all, would you say there is a correlation that these appear to form a linear pattern? Yes, okay. Because if you're answering no to that, then you're not drawing a line. You're just saying no correlation and you're done. Now, with this, and this is how I'm interpreting it, so it's not given in the directions or anything. It's possible with scatter plots to have outliers, and I would almost say that this first point we had would be considered an outlier. An outlier is a point that seems to lie farther away from the rest of your data. And even if you look at the table, this value of 18 seems to be far away from the rest of these values, which, you know, if you think about it, should make sense. There was probably a huge jump in internet access between 1997 and 2000, and now we still see an increase, but it may not be as big of an increase. So what I could do is if I say I'm going to consider this an outlier, because it seems to be pretty far away, when I draw my line of fit, I don't pay attention to where this point is. Because this outlier would change the steepness of the line that I would draw, and that's going to throw off any future predictions, because it's much lower than the rest of the data. So I'm not going to pay attention to this when I draw my line of fit. I'm also not going to pay attention to it when I describe my correlation. So this should be farther away from my line. So if I'm saying that the correlation is weak, it would have nothing to do with this. I'm not paying attention to the outlier. So if you have questions on when you're working through examples, if there's an outlier, if the problem doesn't specifically say, just let me know. But if you notice there's a point that seems to be way far away from everything else, then it probably is. So when I draw my line of fit, and this is why, did everybody pick up a ruler, first of all? Okay, or if you didn't pick one up, at least if one person in your group has one, then you can share them. I do need them put back in there before you leave today. But the reason I had you grab a clear ruler is when you're drawing a line of fit, your line of fit should first follow your data. So, for example, looking at this, I wouldn't want to draw a line like this, because that clearly doesn't follow what my points are showing. So I want to follow my data, the steepness, or even if it's not very steep, I want to follow that. And then you want to be approximately in the middle of your data. So approximately the same number of points in your scatter plot above and below your line. It may not be exact, but for example, I don't want to draw my line up here because all of my points then are below it. I don't want to draw it down here. So kind of makes sense with it. It should be approximately in the middle of your data following the trend that your data shows. So mine, I'll draw through here. It may go through one or more of your scatter plot points. It may not go through any of them. It doesn't have to go through any of your scatter plot points. And then also notice how I drew this. I'm actually starting on the y-axis and it's just continuing. I'm not drawing it through the other direction since I'm not really paying attention to anything to the left of the y-axis. So again, that's a part where you could get points off. It could be wrong if I were to, for example, have drawn my line of fit like this. So if I'm just being careless and just going, just drawing a line that isn't even straight, I'm not going to give you credit for that when it comes to the quiz or the test. So make sure you're really thinking about where to draw that. And then to describe the correlation, so would this be a positive or a negative correlation? Positive, and then would you say again, now when I'm thinking strong or weak, I don't pay attention to the outlier. So the other points, would you say this is strong or weak? I would say it's pretty strong. Those other points are pretty close to it. So for describing the correlation, you just need to say either strong or weak and then positive or negative unless it's no correlation. So strong, positive correlation. All right, so that part is done. Now, to actually use the line of fit to make predictions then, part B says use two ordered pairs to write a prediction equation. And this is where not only are your line of fits probably drawn a little bit differently, but answers are greatly going to vary for part B. You may not have the same answer I would have. So I need to pick 2 points. I'm just going to use a different color so you can tell the difference from the blue. The 2 points you pick do not have to be from your scatter plot. They do not have to be from this table. And in fact, I don't want you to use them if your line doesn't go through it. So for example, I should not pick this point. My line doesn't even touch that point. So why would I use it to write the equation of a line? My line doesn't go through it. So now my line does kind of just barely touch this one. So I could use that point for my prediction equation. But the other 3 points that are in the actual table, well, not including the outlier, I shouldn't use those because my line doesn't even touch them. So then I have to find, or rather approximate, a different point that my line does go through. And I don't want to pick one that would be necessarily right next to this data point. So maybe I'd be looking on this side of my scatter plot. And this is where your graph might be different. So say I picked, actually I'll pick up here. I don't want to go too far past where my last point would be. This is actually at the same x value. But my line, it doesn't go through the data point from the table, but I would say this would be the ordered pair 12, and then on my graph, that's approximately at the y value 65, based on how I drew my line. And then this point is directly from my table. That was the point 5, and then 41.5. And both of your points, neither of them might be from your table. Yes, correct. So yeah, for this example, this is going to be up to you for your notes, how you want to do it. If you want to use the same points I'm using, even if your graph looks different, that's fine. If you want to pick 2 points your line actually goes through, that might be better. You won't have the same answer I have on your notes, but at least when you're looking at your notes, you're looking at 2 points that are actually on the line that you drew. So I would actually encourage you in the notes right now to pick 2 points on your line. If they don't match my 2 points, it's okay. That actually gives us more discussion for part C with those answers. But that really means when I grade your tests and your quizzes for chapter 2, this type of problem takes me the longest to grade because you don't have to have the same answer I have. You're going to have a different answer, most likely. Okay, so once you have your points picked, or if you just did want to follow along with mine, that's okay. Or maybe they line up. I'm just going to write these 2 coordinates under part B. Then you do what we did yesterday, write an equation of a line that goes through these 2 points, and your final equation should be in the form y equals mx plus b. So to write the equation of the line, what do we have to do first? Find the slope first. So change in y over change in x, so mine would be 65 minus 41.5 all over 12 minus 5. And again, if you're using your own 2 points, you're going to get different values. That's okay. It should be close. It shouldn't be so far off, but different is okay. So for mine, I have 23.5 over 7. Now, I know I always said leave slope as a fraction. In scatter plots, especially since if you are using the data points from the tables, you have decimals a lot of the time. A decimal in a fraction is not simplified. If you write your slope for prediction equations as a decimal, that's okay. Even if you get, say, a repeating decimal and you just approximate it, that is okay for a prediction equation. So I actually am going to divide that by 7 and just approximate what my slope is. So I'm going to round it to 3 decimal places, so mine's approximately 3.357. Okay, so these are definitely equations that don't always have nice whole numbers in them. They can look pretty messy. And then I'm just going to pick, I'll pick the point that doesn't have any decimals in it to use for mine. And I'm going to use the point slope form, the y minus y sub 1 equals m times the quantity x minus x sub 1. So for mine, it's going to be y minus the y coordinate 65 equals 3.357 times the quantity x minus 12. And then with this form, I just need to solve for y to get my equation. So I'll distribute the 3.357. So y minus 65 equals 3.357x minus, and if I multiply that by 12, I get minus 40.284. And then I would add 65 to each side. So my equation, which I'll write in the space over here, I have more room, y equals 3.357x and then I get plus 24.716. So this is my equation. Okay, so any questions though on getting the equation? And again, right now if you're using your own 2 points, hopefully your slope, your y-intercept might be, maybe the greatest it's off by is, maybe 5 in either direction. But shouldn't be, maybe off by 10 is a little bit too off. And then for part C, so now it says predict the percent of households with internet access in 2020. So now we're using our data to predict how many households may have internet access in the year 2020 if it follows the same trend. So first of all, make sure you're not substituting 2020 in for x. You have to figure out what this x value would be. So in the year 2020, what would our x value be? 25. So we'd have y equals, for mine, 3.357 times 25 plus 24.716. If I multiply that by 25 and add 24.716, now I get 108.641. Now, the units on my y value, it's a percent. Does it make sense to have over 100%? No. So I would take this to mean, and if this were to happen with this type of scenario, say on a quiz or test, if I were to get this, I would interpret this to then mean, so 100%, because I can't go higher than that. I can't have over 100% of households. So according to my prediction equation, 100% of households would have internet access in 2020. Did anybody use their own 2 points and own equation and get something that was under 100%? Lisa, what did you get? 93.65? 96.65. Lynn, did you raise your hand too? 98.75. Ellie? 99.5. And then, did anybody get over 100%, but they were using their own points, so it was just a different percentage over 100? Okay. So if you got over 100%, you would interpret that to just be 100%. Otherwise, you would leave it, but just showing you have different values. So then, looking at all of these predictions, though, it says, how accurate does your prediction appear to be? Do you think it's pretty accurate in 2020 that close to 100% would have internet access in the United States? Does that probably make sense? Does it make sense to say 100% will have it? Do you think? Probably not. I mean, we can't guarantee that every single household in the United States in 2020 will actually have internet access. There's still households now that don't have internet access, and we're pretty close to 2020. So I would say these predictions, your prediction equation would be more accurate because you didn't quite get 100%. Mine, I probably drew my line in. It's probably steeper than it should be. My slope is too steep because I'm getting a value over 100%. But to answer this, I would say well, how accurate? So I'll just say this. Households in 2020, actually I should have said in front of households, most households in 2020 will probably have internet access, but not 100% of households. So if you actually got one of these values, I would say your prediction is pretty accurate. My prediction, though, is a little high because I don't think 100% of households would actually have internet access. So does that make sense? Are there questions?